Look at this ice cube. It looks still, but inside there is a hidden reality of vibrating particles. In this video, let's learn lesson 1.3, which is changes of state. So we'll be learning what happens when a state changes. So we'll go through the definitions with real life examples. And also we'll learn why temperature stays still while ice melts and how to spot an impure substance like a detective. Let's dive in. Melting point is the temperature at which a solid becomes a liquid. Boiling point is the temperature at which a liquid becomes a gas throughout the substance, where the pressure of the gas is equal to atmospheric pressure. Physical change is just a state change, no new substance is formed. So usually change of state is reversible and it is just a physical change. It occurs when the heat is removed or added. So let's move on to the important points in the theory. So melting is where a solid changes into liquid when heat is added. For example, a block of butter melts. So when we heat a stick of butter, the butter particles gain energy and vibrate faster. Eventually, they gain enough energy to overcome the attractive forces holding them in a regular lattice. Think of the melting point. Imagine particles are like people on a party floor before the music starts. Everyone is standing in their assigned spots in a neat, regular lattice. As we add heat or the music starts pumping, they gain energy and vibrate. Eventually, they have enough energy to overcome the attractive forces holding them back. Now the crowd is dancing, moving, and sliding past each other. That's your liquid. Next is evaporation versus boiling. Don't mix this up. Evaporation happens only at the surface. At the surface. At any temperature. But boiling is a full-blown riot throughout the liquid and only happens at a specific boiling point. So next we have condensation and freezing. So these are the reverse process of boiling and melting. So before, what happened was when the particle was heated, the particle gained energy and moved further away and it melted, boiled, and evaporation happened. But in condensation and freezing, we are going to do the opposite, which is we'll be cooling down the particles. So when the particles are cooled, they lose energy and they move closer together. And attractive forces become significant again. And that's how the liquid turns into solid and gas turns into liquid. Now, can you think of an example of condensation, freezing, melting, and boiling? And type in the comment box. Take a look at the table below. You'll notice that melting and boiling are labeled as endothermic, while freezing and condensation are exothermic. Now, you don't need to memorize these terms. Just remember the direction the heat is moving. So, endothermic is heat in. Think of endo as enter. So, endo means enter. Heat is being entered. So, heat enters the substances to break the particles apart. And that's how boiling and melting happens. The substance gets hotter inside to change the state. Now, exothermic is where the heat exits. Think of exo as exit. Heat leaves the substances and goes outside into the surrounding. As the heat exits, the substance cools down and settles into a liquid or solid. When you look at a heating curve, the flat horizontal sections where the temperature remains constant are called plateaus. These represent a phase change like melting or boiling. So this is the melting point of water and boiling point of water, which is 100. So this graph would explain what happens to the temperature from ice to steam. Now imagine an ice cube at minus 20 degrees. As you add heat, the temperature rises steadily until it reaches 0 degrees Celsius, its melting point. Then we have the first plateau, which is at the melting point. At this point, even though the stove is still on, the temperature stops rising. This continues until every single crystal of ice has turned into liquid water. Now once the ice is fully melted, the temperature begins to climb again until it hits 100 degrees Celsius, which is the boiling point. Then we get the next plateau, the boiling point. The temperature stalls again. It will stay at exactly 100 degrees Celsius until the water has entirely evaporated into steam. Normally, heat increases the kinetic energy of the particles, making them move faster. But during a plateau, the heat energy is redirected. Instead of making the particles move faster, the energy is used to break or weaken the intermolecular bonds, holding the particles together. The temperature cannot rise until the phase change is 100% complete, because all the incoming energy is sacrificed to overcome those physical bonds. So that means during this plateau, the heat energy is used to break the bonds. Now on the left tute, we have a question which is worked example. A student is testing a sample of unknown white powder. It melts between 78 degrees Celsius and 82 degrees Celsius. So this is the melting point. The question is this a pure substance? So no, this is not a pure substance, because pure substances have sharp melting point, which is a one specific number. Since this melts over a range, this substance is impure. And pause the video and go through the step-by-step solution for better understanding. So next we have 3 practice questions. I highly recommend to pause the video and give it a shot. The first question is, explain why the temperature of ice water remains at 0 degrees Celsius even while it is being heated on a stove. So as I explained earlier, the heat energy is used to overcome the attractive forces. Next question is, what is the main difference between evaporation and boiling? Evaporation happens at the surface and boiling happens throughout. Then we have, how can you tell if a liquid is pure water using only its boiling point? If the water has the boiling point, a sharp boiling point, which is 100, we can say it's pure. In exam questions about heating curves, if you are asked why the temperature stops rising during melting, use this exact phrase. The energy is being used to overcome the forces of attraction between the particles. Avoid saying the energy is lost.